Good evening, young astronomers, especially our NAC aspirants, their families, and guests who are attending this event today. We are very happy to launch a webinar series on careers in astronomy, perhaps for the first time. The series will feature several professionals in astronomy and space sciences. And through this series, the students, as well as the parents who are currently logged in, can get to understand if this is what your child's interest gravitates towards. The best way to pursue it, you will get a great guidance through Dr. Mila Mitra, as well as the various other speakers who we would host. This series will be hosted by the very able and the person who has been through it for more than 2 decades, Dr. Mila Mitra, who is the co-founder and academic head of STEM&Space. Today, she will launch this series, as well as she will also talk to all of us about her career journey, which is going to be a very insightful experience for all of us to hear. Welcome, Dr. Mila. May I now introduce Dr. Mila. Dr. Mila Mitra has a PhD in astronomy from Rice University. She has worked for more than 20 years at NASA on various astronomy and remote sensing projects. She was with the COBE project, which later won a Nobel Prize in Physics. In addition to astronomy, she is active in outreach, has conducted several Mars observation events, writes regularly sky watching column in Hindustan Times Next. You'd be glad to know a proposal by her to spread astronomy to rural communities by carrying a telescope on a bike was selected by the International Astronomical Union. Dr. Mila, first of all, I invite you to launch this career webinar series and describe briefly what is it about.
Hello, everyone. Thank you, Chandra sir, for welcoming me today. And I also have with me Mr. Arjun Gulia, who's going to be helping us. So on behalf of STEM&Space, I welcome all our participants today, and especially National Astronomy Challenge participants and their parents. So you can find out more about what are careers in astronomy and what can you aspire towards. So, so let me go ahead and share my screen. So for the first time, we are launching career stories. I know a lot of you think about who is an astronomer. You know, it's not a profession you meet very often. So you might be thinking, who's an astronomer? What do they even do? And how do you even become an astronomer? It's not that obvious. The pathway is a little convoluted. So we are going to talk to you about that. And maybe for some of you who are developing an interest in astronomy and space sciences, it's going to be a great way to learn about it. So today I'm going to talk to you about my career journey, and through that you'll understand what is the pathway I took. And in the next few weeks, I'm also going to be bringing in other experts who are at different astronomy professions. On November 10th, we will have Professor Tarun Shauradeep. So he'll talk to you about the academic point of view, what a professor, what a faculty does, what kind of research they do. And so that's his angle. And that's the best career to aspire towards, of course. On November 17th, you'll find a special guest on the other end of the uh, ladder from Professor Tarun Shauradi. Miss Shreya Santra is a PhD student. She's also very accomplished. She has been involved in many projects, and she will talk to you about what PhD students do, how they look at data, what kind of observations they do. And she, in fact, has a very interesting position because she's working with rovers that will actually go to space. So that's going to be very interesting. Do listen to her on 17th. On November 19th, we have Mr. Divyanshu Poddar, who will talk to us about he's an engineer and a rocket engineer, and he's really a rocket scientist, and of course so are all of us who are giving the talk. But Mr. Divyanshu will tell you how to come into this career from the engineering point of view, with a special emphasis on rocketry. And also he's an entrepreneur, he started his own company. So you learn how that kind of thing works, and you learn it from his angle. And on November 24th, we have Dr. Padma Yanamandra Fisher. She'll be joining us from the US, where she's a research scientist with the Space Science Institute. And from her, we will hear all about how scientists do research careers. And Dr. Padma is also very well known in all our circles because she's very active in outreach, and she tries to involve amateur astronomers with professionals and makes projects that are amateur professional uh, combinations. So I hope through all this, we are giving you a very special look at how people from different careers who started their career path in different tracks, how they were able to go into astronomy and space sciences. And through that, you'll also understand what any of us do, what is the kind of work we do, what do we do on a daily level. And I hope through all this, you'll get glimpses of what astronomers and space scientists do. And so, like Mr. Chandra said, this is the first time we are bringing this, and I hope it really helps all of you understand what kind of careers in astronomy and space sciences you can aspire towards. So, today I'm launching this with my own career path and my own personal journey.
Thank you, Dr. Mila. This indeed is a great selection of people. Not only we believe we would learn from them, but also get inspired because many of them appear to be very, very young. And this is what the youngsters need today. Learning from the experienced people that you have, but also from the youngsters, because that gives us the confidence that so much can be achieved at an early age. Thank you so much. Now that you mentioned astronomer quite a few times, we would really like to understand who is an astronomer and what do they do, because I'm sure they are not in the space all the time. So if you can, help us all know, how they go about their day-to-day activities, would be a great learning for all of us.
So, yeah, so I'm going to tell you today first who is an astronomer. You may have heard the word, but do you know what an astronomer is and what do they do? An astronomer is a scientist. They primarily look at space, as most of you know. The interesting thing about astronomers are, unlike other professions like engineers, software people, uh, graphic designers, we are not able to actually touch and look at the objects we are working with directly. It's all out there, and we have to find them and look at them with different tools. We cannot look at them directly. So, an astronomer is a scientist who looks at space. They look at solar system, planets, moons, asteroids, comets, a lot of things that are in the solar system. They look at stars, they look at interstellar medium, which is the gas and dust in between all the stars. Of course, you know, we are in the Milky Way galaxy. So astronomers study galaxy. What is the structure of galaxies? And are there other galaxies? A recent, recently we've been looking for search for life. It's a very popular topic. And recently, some of you might have heard my talk about that. Um, so search for life. Scientists are looking inside our solar system and outside. And through that, through various missions, they've been able to find exoplanets, which are planets in other solar systems, which could be habitable, like our own Earth. Of course, astronomers look at the whole universe. How did it form? And when did it form? And what is the state now? And evolution of our solar system and our sun. Because remember, why do we do all this? We want to know, how did our universe start and how will it develop? We don't want to be surprised by our sun suddenly not giving us light. We want to know exactly what is the age of our sun, how long will it last, what is the different wavelengths of light we give. So it's not just up in the air, it's actually through understanding all of these things, we get the knowledge that will help us understand how we were formed and how our evolution will happen. Okay, so what kind of tools do astronomers use? I just told you that we cannot touch them, we cannot look at them directly. Everything we find out are through different tools like telescopes. You already know astronomers use telescopes, but not just ground telescopes, also big observatories, radio telescopes like the image you see at the bottom, and of course, satellites that carry telescopes like the Hubble Space Telescope. Also, there are satellites and spacecrafts and rockets that go and gather data for us. Then, of course, astronomers use different tools like spectrographs that give you the data in a different form, which is called spectrum. Many astronomers use cameras, maybe as simple as the DSLRs that we have at home, but maybe much more powerful CCD cameras, which are charge coupled device cameras. And those are what are attached to telescopes at the observatories. So they give you images that are really high resolution. And through that, you can make a lot of inferences about what you are viewing. Okay, so I'll tell you a little more about how we work. Okay, so mostly astronomers take observations that are at the ground, which are optical, or in space, like Hubble Space Telescope, like Chandra, like the new James Webb Space Telescope that's also going to be coming soon. Then, when they get the data, they analyze the data and look for trends and solve the problems. So, here's how I'll give you an example. You can look at an image that shows a little moving object, and that is actually an asteroid. So it's only when you take look at the same part of the sky for many days or for a long time, and then you can see an object moving. So this is the kind of work astronomers do. This is a very simple case, but they take data and then look at it and they try to find what the answers are to the data. Okay, so we look at astronomy data, we collect it, we analyze it, and we do research to reach a certain conclusion. Okay, so what we do not do, what astronomers do not do, are tell your horoscope, look at your palms, or tell you something based on your zodiac sign, because those are astrologers. So please do not confuse between astronomers and astrologers. A lot of people make that confusion. And if you ask me what is similar between them, there is something similar. They do look at the sky, both of them. They do look at positions of objects, but how they interpret them is different. Astrologers interpret them and try to make a relationship with your life, whereas astronomers just interpret them to get the science and figure out what is going on in the universe and how that's going to affect us. So, one more thing, a lot of people get confused with astronomers, and astronauts. And I know a lot of you kids, I asked this question many times, who wants to be an astronomer? And I can't see you right now, but I'm sure half of you would be raising your hand. So, astronaut is a different thing. Astronaut are people who go into space. And I'm proud to share that India is also going to launch their own astronauts in the next 2 or 3 years. We've already started training them. So, to become an astronaut, you don't have to follow the same career track. It's a different track, and you have to learn how to, do the train. You have to be trained to actually stand conditions in space. And of course, many astronauts do come from science engineering backgrounds, and they do have an astronomy background, so they can figure out what to do when they go into space. Yes, so I hope that was some introduction of who's an astronomer. So basically, an astronomer is a scientist who does all these kind of different kind of things like I just mentioned. And I hope that will inspire you to also go into this field.
Okay, thank you, Dr. Mila. Thank you for clarifying, and at least for me, that astronomer and astrologist are two different set of people. And my bit for the youngsters attending this is, when you work with grit, determination, and passion, then you need not visit any astrologer. And if you pursue this path, you definitely can be an astronomer going forward, if you so like to become one. So, Dr. Mila, please help us understand, and our participants would really love to know, what kind of career path can one aspire to in this particular field?
So, as I just mentioned, some of the things that astronomers do are get data from somewhere, look at it with the data analysis, and do some research. Of course, there are other type of people now who are doing engineering and other kind of things. So let me go ahead and address that. So where do astronomers work? They might work in academia. What does academia mean? It just means in education, higher education, academics. So that could be, you could be faculty teaching at universities, or you could be doing research and teaching. So that's academia, is faculty positions. And a lot of people in astronomy do aspire for those kind of careers. So there are a lot of research facilities, government labs, national observatories, and other labs where you can do research. And that would include all the way from our ISRO to, to NASA, to JAXA, the Japanese Space Center, to European Space Agency. But let me come back to India. There are government labs and observatories like the Aries Observatory, the GMT in Giant Meteor Radio Telescope. There is an observatory in Uti. So we have many national observatories. We have a solar observatory in in Rajasthan. So we have many observatories where people can be trained to work. And you can also be absorbed in different labs with government positions. So that's not all. There are many people who work in outreach, such as planetariums, such as also with the telescope support. And there are jobs in the private sector too. So some professions, research scientists, college professors, you can go in from the from the engineering track, like some of our colleagues have done, and some of the speakers will be talking to you about that. And I know many of you kids are interested in engineering. So if you're interested in rockets, missions, satellites, you can go into these careers from that point of view, where you not only plan the mission, you figure out how, for example, a satellite, you have to figure out how it'll work, what data it will take, what payloads, which is science experiments, will go on it, how that satellite will exactly reach where you want it to. So, yeah, there's a lot of engineering involved in this kind of planning. There are scientists who do remote sensing. And now coming, there are of course coming towards the bottom. There are other scientists who are related, like meteorologists, climatologists, and engineers. I've already mentioned. But you can even go into other career tracks because now the world is opening up. There's a lot of outreach. There's social media. There are uh, there are journals online, so you can also go into being a science writer and outreach person if that's what you're interested in. And there are many planetariums and science centers, and we work very closely with Nehru Planetarium in Delhi. So planetariums do a lot of astronomy, and they share it with students and the public. So that's also a good position to go into. So I hope you've got an understanding of a whole range of careers that you can go into if you if you get into this career and then follow a little bit of different tracks. For example, for college professors or researchers, you might have to get a PhD. For outreach or writing or planetarium directors, you might have to build up on your outreach and speaking and social media skills. And of course, remote scientists, remote sensing scientists, meteorologists, climatologists, you have to build up skills in that background. And probably most of these people will have a PhD, or at least very strong uh, skills, that they have to build up specific to those that kind of training that is needed. Yeah.
Okay, thank you, Dr. Mila. That's really so many careers within astronomy that I'm sure we would have learned some of these for the first time. Thank you very much for detailing them. And what I would now like you to do for our young aspirants, why don't you share your own career journey, your own personal journey, and at what age did you really get interested, or you decided to be an astronomer? Did you have to attend special education? What kind of education institutions you went to? So, how did you figure out, what should be your career path? Did it happen by design, or just one thing led to the other? Please help our children who are participating in this to benefit from your own experience. We would be very, very happy to learn as much that you can share.
So, as you know, astronomy is a very offbeat career. So, you know how, I mean, most of you are here in India. Most of your parents will say, give the engineering exam or give the medical exam if you're interested in science and math. And otherwise, of course, there are many more careers nowadays in economics and history and things like that. So, how does a kid say, I want to go into astronomy? Many people don't say it when they are that young. Most people understand that they want to go into astronomy at a slightly later stage, like in their undergraduate stage. But I am an exception. I did say when I was in the eighth or ninth itself that I want to be an astronomer when I grow up. And in fact, a lot of people still remark on this, people that I knew in school, because they said you're one of the few people who actually went ahead and became what you said you wanted to be when you were in eighth. But I have a special case because my father was also in a similar career. So maybe that influenced me. So, for all of you, who knows when you'll come to that conclusion? But I want to share that some of the students who have worked with us and have attended workshops with us do say that they're very interested in astronomy and do want to follow that career path. So, based on that, I'm going to share. Uh, Again, I'm going to share my journey, and um let me talk about first uh, how in general you go into this kind of career track, and then I'll share my personal journey and what kind of projects or research I did at every step. And maybe through that you'll understand one specific career track. And all our other guests will also share different branches that they followed. Okay, so let me start with how you can proceed, or you would have to proceed if you wanted to become an astronomer or a space scientist. So, some of you are in middle school, high school. So, the first thing, parents, is these kids will have to take science, math, and probably computers. All these fields are very encouraged, and you can only go into it if you really like these fields, science and math. And what will help? Taking STEM projects like what is STEM? Science, technology, engineering, math. And as some of you know, we are STEM and space. So we also try to get kids interested in STEM. So, STEM, robotics, doing science projects, doing Olympiads, all these will really hone your skills. And later on, these will really help you get college admissions. So, the first thing is you need to go get into science and math and hone your computer, STEM, and robotic skills. So, after that, you go into college. What kind of colleges should you apply for? You can apply for pure sciences like physics, math, chemistry. Uh, Although there is a subject called astrobiology, that is a different domain. So that's not the direct path to go into these topics. But yes, nowadays it's interdisciplinary, and maybe you can come into that from that field also. Some people go into it from the engineering background. They we And the best engineering tracks to follow would be aerospace, aeronautical, or mechanical engineering. And remember, this would take about 3 to 4 years for your BSc or BTech degrees. Mostly for astronomy or space science careers, even a BSc or BTech is not enough. So do realize, kids, that you'll have to spend a lot of years getting a higher education, and that's okay, that's fun. So don't worry about it, but do keep it in mind. So, what would you have to do after your BSc? You would have to go to graduate school, and that you can do you can get an MSc, which is a master's, or a PhD. And master's would take about 2 years, and a PhD would take about 4 to 6 years. And remember that in India, you can only go to graduate school in astronomy and space sciences. There's almost no undergraduate place in India. So, graduate schools in India include names like Indian Institute of Astrophysics, Indian Institute of Science Technology, of Space Technology, which is ISRO's own institute. Then there's IUCA in Pune. There's ICER, and I'm just giving the abbreviations. That's how they're known. And some of our speakers will be from these places. And ICER, IISER, there are 5 locations, and these are very well known for the sciences. And yes, so that's some of the places. Of course, Delhi University, any of the higher level astronomy institute universities would also have astrophysics graduate school. So I hope that's clear to you. This is the education pathway. And now I'll start with how I went ahead, and maybe you'll figure out which of these points or these tracks I hit on when I was going through it. Okay, so I did my BSc in physics. Like I told you, BSc in physics is probably the best way to start, unless you're coming from the engineering background. And I went to St. Stephen's College in Delhi. Some of you may know about that. It's a great institute, and the physics is very good there. So, but you can do physics anywhere in India or abroad, and that will prepare you for it. So just to keep this fun, I want to show you, I'm just going to sneak in some of my personal pictures. Okay, so just to show you that physics is not all being a nerd and not all just work, work, work. It is. But here I have a picture of all of us having tea when we were in St. Stephen's College at the canteen, because yes, you have to make time for fun also. So then I went for my MSc and PhD to Rice University in Houston, and that's in Texas in the US. And a lot of you know by now that if going abroad is a good way to get into a very good career track for, especially if you're doing higher studies in like a PhD. So coming back to rice, I don't know if any of you know, if any of you have heard the famous speech by John F. Kennedy. Uh, that was the speech where we said we choose to go to the moon. And his speech is the one that triggered the interest and the space race in the US. And just after he gave the speech is when the first man landed on the moon. And he gave his famous speech at Rice University. So that's an offshoot of something very interesting that Rice is known for. So, what did I work on for my PhD? So, you know that if you're doing a PhD, you have to actually find a problem and you have to solve it. And you have to do it in a way that nobody has done before. It's in any field, not just physics, not just astronomy, but in economics, in psychology. All of these, you have to define a new problem and you have to solve it. The problem I worked on was very interesting. It was part what is called observational astronomy and partly bringing that data back home and solving it. Okay, so I went to this set of observatories, which is called the Kitt Peak National Observatory in Arizona. They're very high up. Observatories are usually on mountains so that the atmosphere uh, doesn't disturb the kind of data you're getting. And the light pollution in the cities also becomes a lot less when you're that high up. Okay, so I took data of what are called nebulae. So, what are nebulae? When the sun, I don't know, I'm just going to go quickly through it. I'm not sure if all of you will understand, but the sun, how does the sun power itself? The sun powers itself by a process called nuclear fusion. It fuses two atoms of hydrogen to create helium, and it keeps doing that to power itself. Gradually, as the sun gets older and older, it keeps on using different gases to do the same equation, nuclear fusion. At some point, when the sun is old enough, it can no longer, it runs out of gases, and at that point, it can no longer support itself through this powering, and the sun blows off its outer layer like a balloon. And that's when it becomes a nebula. And you might have seen Orion Nebula in the sky or other such beautiful nebulae. And so, what I did is I observed a specific nebula and I brought that nebula data back to the university. I worked with it with software and data analysis to figure out how that nebula blew out and why does it have this shape. Does it interact with the gas around it? So, all kinds of problems. So that's what astronomers do. They get some data and then they look at it and then they create a formula or a research topic out of it that they try to answer. So here's a beautiful picture of not the nebula I observed, but another nebula. And through that, you can see that at different wavelengths, it looks very different. And that's why there's a lot of research to be done about, most of us just are used to looking at it visually and saying, wow, look at that, it's so beautiful. But what is it? Why does it have these filaments? Why in some wavelengths does it look different? So that's the kind of research you would do. And yes, it is tough to get a PhD. You have to sweat it out. But if you get it, then you've gone through a beautiful journey and you've actually learned a lot and you are super confident of being able to take your work forward and also working with students at that point. So now I'll share a couple more fun things with you. The unexpected bonus of being at Rice University is that it was close to Johnson Space Center in Houston. This is one of the NASA's, and it is the NASA where astronauts train. So there's the Mission Control Center at Johnson Space Center. And this is one of the training labs where astronauts work underwater to get the practice of how it is like to be at space. But the interesting story I want to share is because we were so close to Johnson Space Center, a lot of astronauts from there came to Rice University to train in astronomy and physics. So we had the good opportunity to interact with several of them. So I'll show you a personal picture of a wedding. And you can see me down below at the left. And now this lady who is just above my picture is an astronaut Shannon Walker. And I don't know if any of you know this news, but she is going to be flying next week in the mission. That's a SpaceX Falcon and NASA joint mission. She's going to be flying to the ISS, and they'll be there for several months. So that was a really interesting experience I had, not just with her, but I got to know at least 2 or 3 astronomers who were also, in spite of their glorified futures as astronauts, they also had to come and do some courses in astronomy and physics and math, and they had to interact with all of us students also. So you never know where you'll be at the right time, and you keep your eyes open, you'll get a lot of interesting opportunities. Okay, so after that, where did I go? I just want to I've worked for more than 20 years, so I'll just give you the briefest glimpse. So where did I go next? Again, I was lucky to get a position as a postdoc. What is a postdoc? After you get a PhD, you can follow it up with postdoctoral studies. And I worked at NASA Goddard Space Flight Center, which is another NASA. And again, I got very lucky because I worked as a support scientist. And what is a support scientist? A lot of missions have scientists that support what data is going to come. This is a satellite. So I worked with a support scientist with COBE, Cosmic Background Explorer. It is a satellite that was going around and taking observations in a wavelength called as microwave and also infrared. And some of you might know these are different wavelengths. I don't know if you know the spectrum, but what the spectrum you see is from violet, indigo, blue, green, yellow, orange, red. That's the rainbow spectrum that you see. Outside of red, there are wavelengths like infrared that you cannot see, but you know nowadays that infrared guns take the measurement of heat, for example. And similarly, on the side of violet, there's ultraviolet. Okay, so like that, there are different wavelengths we cannot see, but different instruments can sense them. So I worked with the Cosmic Background Explorer. And what was that looking at? It was looking at the background radiation of our whole universe. Okay, so what does that mean? You know, our universe was formed as a result of Big Bang. And what is that? There was a small point that something caused it to explode. And that's why it's called Big Bang. The same noise that a balloon makes, bang, that's how it exploded. And slowly it expanded, and gases were formed. Out of the gases, clumpy stuff were formed. And out of the clumpy stuff, solar systems and suns and planets were formed. And eventually, life was formed. So the Cosmic Background Explorer was looking for the background of the universe. If the Big Bang theory was true, then theoretically the universe would have been at 3 degree Kelvin temperature as a uniform temperature, and most of the gas and dust would be uniformly spread. That was the theory, and the Cosmic Background Explorer did prove it to be true. And so you can see this kind of data. It may not mean much to you, but all it means is most things are uniformly spread. And this was the 3 degree background radiation was proved. And this experiment, or this mission, Cosmic Background Explorer, did get the Nobel Prize in Physics in 2008. So it was a great project to work with. Okay, so that's what I did to come to that career track. And I'll leave it here, CSP.
Yeah, thank you, Dr. Mila. This is very, very insightful, and I'm sure it might already have given some goosebumps to some of our children and making them uh, feel like definitely going in for careers in astronomy. A couple of quick things, children. One, uh, a teacher or a scientist for that matter is happiest when the students do better than them. So if Dr. Mila decided to do this while she was in class 8, I'm sure there'll be some of you who might want to decide maybe in class 4, class 5, class 6, or even earlier. The second bit, the picture that Dr. Mila shared of her days at St. Stephen's, if you had seen, there were nearly six or maybe, seven uh, girls and only one boy. So that is what we need, more and more girls to come in this field, because you can, with your empathy and compassion, do even better. So thank you, Dr. Mila, for that. We are getting a lot of questions, and before we get to the question answer, just one more thing, if I can ask you, what kind of skills and subjects do you think the students should opt for, right during their primary or middle school, so that they can get into STEM careers? And we believe that STEM careers, particularly in space, in the next decade or so, will be the highest employers.
So I think I said this already a little bit, but basically, because I already addressed this in my presentation, but yes, let me share it again. And I think a lot of people have those questions. And please keep in mind that, okay, so let me quickly go through these. Yes. So I'm seeing a lot of questions in this, and please don't worry, parents, because I'm doing the introductory talk, and all the people who will come after me will actually give you very specific information about the colleges and about the institutes, and that's one reason I did not do a slide on that. But since so many of you have questions, I will have a slide on that when I introduce my next guest on next Tuesday. Okay. So, yes, you have to build up your science and math skills, and that is STEM, and definitely programming if you can. And at the college level, you should go for either from a pure science career from physics, math, and chemistry, or through engineering. And yes, what kind of, some people asked, is it necessary to do a PhD? And you don't have to do a PhD for all of these fields. You only have to do a PhD if you go into research or faculty kind of careers. That's right. Some people said that they're not sure that PhD is needed. So you're right. Uh, there are places that you can apply through entrance exams like Indian Institute of Space Technology, ICER, Indian Institute of Science. All of these are through the JEE exam, the joint entrance exam that you give for engineering. The same exam will enable you to go to these, or you this also have separate entrance exams. So when you're in the 11th and 12th, you start getting ready for both of these kind of exams. Okay, so somebody asked, yeah, so I'll come to questions later, but uh, that's the main pathway. Do focus on science and math for now. Well, if you're very young, if you're in elementary and middle school, you should actually focus on everything, because even your learning English or your creativity or your design skills, all that is going to build up. So don't worry about it if you're in elementary school. Do learn everything, but do keep a focus on hands on learning, and do keep an interest in science. Yeah, that's it. CSP.
Okay, so that's awesome to know. And what we would like to do now, we would like you to take some questions that we have from our participants. In fact, there are innumerable questions, and
Yeah, I know. And
we'll
okay.
attempt to answer and take your time, a couple now. And children, you can continue to ask these questions during the various outreach and talks and sessions that would be
Right.
organized by Dr. Mila. So the first question I have is from Babita Yadav, and she says, "Ma'am, I have a doubt. Does space scientists only get jobs in institutes like NASA and ISRO, and those national institutes of other countries, or are these or they can get into private institutes as well?" So her question, as I can understand, is do they have to go for these government institutions only, or are there any private institutions which can help them take employment in?
So most of the institutes are still government institutions, and it's not just NASA or ISRO. There are many related organizations. There's the Indian Remote Sensing Organization. There's National Physical Laboratory and Physical Research Labs. So there are different climate institutes. So there are many different institutes that you can apply for, depending on your specialization. But also there are, just having so many industries also sprout up other related industries. So just because there's an ISRO, there are private organizations that manufacture satellites, that do data analysis of satellite data to see how it applies to agriculture, that do communications for satellites. So there's a lot of related industries in, and you'll get private jobs in all these industries. So it is a bit specialized, but there are private institutions everywhere, even in the US, not just at NASA, but there are all these aerospace companies too, like Boeing, Northrop Grumman, Lockheed Martin, and some of them have branches here too. And so all of these will do aerospace related, not directly astronomy maybe, but a lot of the engineering component, even rocketry is a big thing, because we just see a rocket fly off, but how is it manufactured? How does it withstand all the heat? So all these things take a lot of people of different skills, and there are other private engineering institutes that, yes, you can apply for, definitely. And there are a lot of them now. Nowadays there are more and more in India also.
Okay,
Yeah.
thank you for that. So would organizations set up by people like Elon Musk and Richard Branson also qualify in this?
Yeah, that's exactly true. I mean, those are, of
Yeah.
course, the best examples of it.
Okay.
SpaceX, but we have smaller institutes, and you will meet one of them. My guest, Mr. Divyanshu Poddar, he's doing a small institute on education through rocketry, and I have many other colleagues who are doing, small organizations, but they are doing engineering work that directly feed into this kind of work, space sciences industry.
Okay, wonderful. Thank you. Thank you for answering that. I have next question from Saloni Agarwal. Saloni says, I plan on pursuing physics for my undergrad and then astrophysics or astronomy. I am an average student, so should I take such a difficult academic option? And she also asked, I have a doubt whether one has to do a master's degree in physics for becoming an astronomer.
Okay, so very good question, Saloni. And anybody whose questions we don't get to answer in these tracks, I'm going to try to answer that for you next time. But yeah, astrophysics is a tough career. Uh, you have to be quite at the top. And I don't, Saloni, the way Indian schools work, that they make 11th and 12th very hard, and then suddenly when you go to college you do find your spot and you start really liking it. So don't worry about it, but uh, don't worry about being at the top right now, but do keep in mind that you have to be really good in physics and math to actually do very well in these fields. Okay, so that's yes, BSc physics would be the right way to go. And the masters, you can do it either way. You can do masters in physics, or you can do masters in astrophysics, because at that level you do start finding masters in astrophysics even in India. So but unfortunately, even in India, There would be fewer places you could do a master's. Most of them would encourage you to do a PhD. So that's there. But yes, you can do a master's in either one.
Okay, thank you, Dr. Mila. I don't have the name of the person because perhaps the person has chosen a fictitious name, but the question is, I have a doubt. What is the difference between a research scientist and an astronomer?
Okay. So a research, yes. Okay, so like I showed you, an astronomer can do many things. Many astronomers do research, but there are also astronomers who don't do research, uh, who just do other things. Like there might be faculty who don't do research, but who just teach at some of the colleges. Okay, so there's teaching. There are people who just do outreach, who work in planetariums. There are people who work in labs, supporting the observatories, supporting the data analysis. There are astronomers who are into writing. So or there are many astronomers, not just astronomers, but yes, astronomers, you would either be doing research or you'd be doing these other kind of things I mentioned, which is teaching, outreach, working in labs. But there are also space scientists, many of whom are not in research, they are in engineering, and they support all the industry that goes into rocketry, satellites, and using the data that comes from the satellites. So, yes, you may not have to do research, maybe just build up your data analysis skills, and you can get some kind of positions from that direction also. Uh,
Okay, so Mila, yeah, there is another question. Thank you for answering this. Shubham Agarwal wants to know if he wants to get a career into analyzing the data that is studied through telescopes. What kind of graduation degree he should opt for? Should it be BTech or BSc?
So in that, Shubham, from if that's the career you want to go into, and that is of course a very good choice nowadays. Uh, so you can go from both directions. You can go from BTech or BSc, but definitely you have to build up your programming skills. And you can maybe I can address that later, or one of our guests can address that. Which kind of programming skills do you need to build up? Yes, but you need to build that up, and you'll also have to get the background of at some point, maybe at the master's level, of what kind of data, what does it mean. It's not enough to just use a software. You'll have to know what you're looking for. uh, you have to know what the data is showing you when you analyze it. So of course you will have to have some astrophysics or astronomy background at some point, but for your bachelor's it's fine, you can go into it from either of the directions.
Okay, thank you for answering that. Mila, Sajir is very curious to know how could you manage admission in Saint Stephen's and Rice University?
So, I mean, that's a whole different ball game, as you might know, because I myself have a daughter who just went through 12th, and Chandra sir himself has a daughter who is now in 12th. And nowadays, it's very difficult. In our times, it was also difficult, of course, but somehow it was not as much pressure. And yes, obviously, I did well, and I was also lucky that I got it. But uh, that's a different kind of question. But for St. Stephen's or Delhi University, you know the answer, that you have to do very well and get very high scores. Right now there's no other option. But to get into graduate school, there are many other things that they consider, especially graduate school. Kids going into undergraduate school still have to do very well, but uh, but going abroad, they see a lot more things that you have, not just your marks. So they will see things like, have you done any projects or internships? Have you done very well in your GRE or SAT? Have you done something special like give talks, work somewhere for just even a month? So my encouragement to you is, uh, getting into college, I can't really help you. But after that, or even now, you can do some projects. You can even choose to do a project with us, because we do a couple of things like that through the year, and build up some skills, build up your resume that shows you've done these kind of things. Of course, Olympiads, all of you, many of you are doing the National Astronomy Challenge. So just doing, even showing that you've done Olympiads, all these things build up your resume. And that's what they look at. They try to see that how you've stayed involved in different astronomy and space related activities, web, activities, workshops, internships, Olympiads, all of these you can build up even while you're a student.
Thank you, Dr. Mila. Dr. Mila's humility you all heard. Let me tell you, children, if you want to be a scientist, the only thing that you need to remember is, sleep is a luxury. So
Right.
work hard.
Right.
Okay, so we have another question from Mokshi Agarwal. Does Kobe look for dark energy?
So Kobe did not look for dark energy, and there are other missions that are looking for dark energy. So Kobe looked for, so it was measuring the sky in that wavelength, and just trying to see if it was uniformly spread over the universe, or wherever they could see and observe it. So not dark energy, but microwave energy.
Okay, thank you. Uh, I don't know how much time we have. Probably, one of the last questions. The question again from a fictitious name. I have doubt if it is compulsory to do PhD and master's degree for astronomy.
Okay, so yes, that is a legitimate concern, because you're not, it's pretty scary to put your child in a career path and say that, you're going to have to devote more than 6 7 years to that career before you get out of it. So that's a good question. You have to get a PhD if you're going on the career track of uh, faculty, which is professor positions, or maybe even some of the research labs, even in India and even abroad. That is a requirement. But if you're going for careers that are in space applications, in software, data analysis, uh, or engineering connected to space industry, then you do not have to get a PhD. You could be fine with a bachelor's, or definitely a master's. Yes, so please do the research of which career path, once you're going from your BSc physics or BTech engineering, when you're going to your next step, you should do this research and try to figure out which direction you want to go, because then you have to apply to the right places.
Thank you, Dr. Miller. We are inundated with questions, and children, thank you so much for all your questions. Because of paucity of time, we won't be able to take uh, any more questions today, but you could continue to ask these questions, because Dr. Mila encourages questions, and during the other sessions, you are most welcome to ask as many questions. I would really like to thank all our NAC aspirants, their families, and the guests who are attending this event today, for taking out your valuable time. And it has indeed been a pleasure to be with you, and for you to patiently listen to Dr. Mila. With that, I would like to close the event by saying that you must attend the entire series, and Dr. Mila would perhaps tell you briefly about the next one as we sign off.
Right. So I just want to end it with, uh, after all that, what do I do now? So now, as you might know, I'm co-founder of STEM&Space. And through that, I've taken a different track now. I want to work with students. So I'm more involved in education and workshops and outreach. Here you see me doing a solar eclipse observation, and this is with public. So there were more than thousands of people who would be coming to this outreach, because people are interested in seeing astronomy phenomena. I do interactions, and for all of you kids who've become our national astronomy challenge participants, here is a picture of me with guest speakers at a previous National Astronomy Challenge. Okay, so recently I did give a talk at the Global Hands on Universe conference. So, yes, now I do education, outreach, and workshops. So, next in line is a very special guest. And, it's very difficult to get a person like that. So, I hope all of you will join in and I hope he'll find time to answer some of your questions. Next Tuesday, November 10th at 5 p.m., we have Dr. Professor Tarun Shauradeep. He is the professor and chair of the physics department of Indian Institute of Science Education and Research, and that's what ISER stands for, ISER Pune. And he was previously the faculty of IUCA, which is the Inter-University Center for Astronomy and Astrophysics. So he's been the heads of two big institutes in astronomy and in physics. So you can ask him a lot of questions. Additionally, he's also involved in gravitational wave astronomy, and he is the spokesperson for the Gravitational Wave Observatory, which is LIGO, which is being built in India. So do bring your questions, and what my team and I will do is get hold of some of the questions that we could not answer today, and maybe make up a couple of slides that will answer your questions in the next few sessions, just as an introduction. So thank you, everyone, and thank you, Chandra sir, for hosting this talk, and thank you, Arjun, for supporting it, and all participants. I hope you got enough answers to your questions, and let's so do join us next Tuesday, and we will inform you at that time of the subsequent sessions.
Thank you, Dr. Mila. I'm sure the career stories in astronomy and space with you will create many success stories for our participants. I wish you all great luck and continue to pursue this wonderful journey of learning and growing. And thank you, Arjun, for organizing this event for all of us. We sign off. Thank you.
Thank you.